Alright, so shall you need more time? Just let me know. But we are going to start now with our 3x3 examples. Alright. Okay. So now we are working with a 3x3 system. It means 3 unknown variables, 3 equations. From the system, for the 3x3 system, what we want is to reach a triangular shape. The triangular shape means here, if I can do this. Okay, this is a triangular shape where for one equation of the 3x3 system we have just one unknown variable. For another equation we have two unknown variables, and for the last equation we have the three unknown variables. So this system here, it is in triangular shape. Why it is important to have a system in a triangular shape? Well, because now we can do back substitution. So this is, can I write here like this? Triangular shape, something like that, right? So that is the triangular shape. Then we can apply back substitution. Okay, so back substitution means that we are going to take the equation, the first equation, the equation with just one variable, and we are going to solve for that variable. So here, when we divide both sides by -3, we are going to have z equals +3. Then we take the second equation. I think this is getting messy. So equation A, equation B, and equation C. Okay, so we start with equation A, and from equation A we got the value for the unknown variable z. Then for equation B, I'm gonna write it here, 3y plus 5z equals -3. So for equation B, now that we have a value for z, see what happens when we substitute that value. Now we have an equation with just one unknown variable. That unknown variable is y. So solving for y, we got 18 on the right side here, and then we divide by 3 both sides, and we got y is equal -6. Okay. Then to work with equation C, so this is -2x plus 2y plus 5z equals -3. Okay, so now that we have z and y values, so see what happens when we substitute those two values. -6, +3. Now look that we have just an equation with one unknown variable, which is x. -3 here, and then we have -6, and then when we divide both sides by -2, we got that x is equal to +3. So see how easy we did this when we have a triangular shape? So the solution is 3, -6, and 3 again. Okay? Remember, now this is not an order pair, this is a triplet where the first value is x, the second value is y, and the third value is z. Okay, you are going to start seeing triplets. I started working with triplets on calculus 3 when we start working with 3D shapes. Okay, so yeah, 3 coordinates x, y, and z. Okay, because now we have a 3x3 system. In terms of real life application, when you are working, I don't know if you like digital art, but if you are working with assets, creating digital art, for example, in a video game like 3D, anything that you see there in a 3D environment has the developers use triplets to locate the position in a 3D space environment. Okay, so x, y, and z is something that is used when we are working with a 3D environment. Okay, but you don't need to worry too much about this yet. Just focus on on 3x3 system, triangular shape, basic solution, and getting the solution. Okay. Any questions here? All right. I'm going to skip that one for a moment. So let's practice back to solution. So I should write my system here. Let me write the system. So 2 equals -3. Use different colors. If I can I use different colors? Yes. All right, so here is our 3x3 system. And this is clearly not a triangular shape. So now I'm going to give you, I'm going to show you the step that I follow to turn a 3x3 system that is not a triangular shape into a triangular shape. So there are a few tricks that we need to do here. Okay, and this is a good example because I can show you all those tricks. Again, remember, you want to avoid negative fractions or decimals, okay, on the system. Sometimes it's possible, sometimes not. As long as it is possible, you are going to try to do that because it will be the optimal route to follow. All right. So first thing that I'm going to do, I'm going to name my equations. And here, naming my equations is going to be important because now we are going to start working with 3 different equations at the same time, and things are going to get confusing. Okay, solving this system and turn it into a triangular shape, it's, it's not going to be easy. Okay, not because it is a complicated exercise. Is that it is very tedious. Is you need to write a lot. You need to go. You need to make sure that you are selecting the optimal way of solve it to avoid any inconvenience during the process. If you miss an every time in the middle of the whole process, you're going to get a wrong solution, and just by just a tiny line there, which is a negative sign, and sometimes like fixing that problem once you finish working with the exercise is more complicated, so you will need to start over again. All right, so let me show you how I like to solve these exercises. The first thing is that my goal is to have the following triangular shape: X, Y, Z, Y, Z, and Z. Okay, so this is what I want to have, a triangular shape. It doesn't matter if Z, the equation with just one variable is at the top or in the middle. The important is that at least one equation has just one unknown variable, the other one has just two unknown variables, and the third one has the three unknown variables. Okay, so I'm going to try to follow this triangular shape. The other thing that I will do is that, because this is the shape that I'm going to follow, is to have the equation at the top, one that I can use to eliminate the x term from the other two equations. So what I'm going to do because the leading coefficient of equation B, or the coefficient of the x term of equation B is positive 1, and that is a convenient value to have, because when we can manipulate the multiplication here, if we need to do multiplication easier when we have just one. Okay, so what I'm going to do is to change the order. So equation A and equation B are going to change the order. So let me move equation B on top of equation A. I just change the order. That's something that you can do here. There's nothing wrong here. It is completely fine. Why am I doing that? Again, it's because x, the term x has a coefficient of 1. Okay, so you will see now how I'm going to use that coefficient of 1 to eliminate the term of equation, the green one, which is equation A, and the purple one, which is equation C. Okay, so now my goal is to eliminate x from equation A and equation C. All right. Using equation B. Okay, because now the coefficient of the term x term of equation B is 1, I'm just going to focus on what will be the opposite value of the coefficient of the term of the x term of the equation that I want to eliminate. So let's focus on equation A. Okay, so let's focus on the x term of equation A. So that term, the x term, has a coefficient of positive 2. The opposite value of positive 2 is negative 2. Okay? Since I'm going to use equation B to eliminate that term, it means, what it means by using equation B, it means that I'm going to add equation A and B, okay? And I hope to cancel the x term. At this moment, if I add both equations, equation B and equation A, I'm not going to cancel the term that I want to cancel, which is x. Okay, you are going to see that, yes, you are going to cancel the term with variable y, or the y term, and that's completely okay. But my intention here is to show you a general process to solve a 3x3 system. So that's why I'm going to stick with this shape. Okay, eliminating x first and then eliminating y from the third equation. Okay, what I'm saying is that this is not the only method or the only process or the step that you are going to follow. Okay, but this is the general, for me, is like the general steps that you are going to follow, and you are going to be okay if you follow them correctly, solving 3x3 system. Okay, so right now if I add A and B, I cannot cancel the term x. So I need to do a modification. I need to multiply equation B by the opposite value of 2, which is negative 2. So this is what I'm going to do. To get the new A, okay, because I'm going to eliminate the x term of equation A, so I'm going to have a new equation, a new A equation. The new A is going to be, I'm going to construct, or going to have the new A from 2 times negative 2 times equation B plus the equation A, the original equation A. How this is going to look like? So how do we multiply B by negative 2? So we multiply the entire equation by negative 2. Okay? And then we add them together. Okay, so this is what I'm doing here. So let me do the multiplication first. Or should I just... Okay, what you are seeing right now is the multiplication of negative 2 on the top by equation B. But I haven't distributed it yet. I haven't distributed negative 2 within all the component of equation B. So that's what I'm going to do. So I'm going to erase the parentheses, because now I'm going to distribute negative 2 with all the component of equation B. Okay? So I'm going to have negative 2x, then okay, so then I'm going to have positive 2y, and then I'm going to have negative 6z, and then I'm going to have positive 4. All right? So on the top, you are seeing the multiplication of equation B by -2. Keep in mind, I'm not changing equation B. I'm not changing equation B. I'm changing equation A. So that's what I'm going to do have is a new equation for A. When I add these two equations, the term x is get cancelled, plus 3y minus 7z equals 1. Okay, so new A is 3y minus 7z equals 1. Okay. I'm gonna leave it there for a moment. Now I'm going to do the same process, but now I'm going to focus on the extent of equation C. Okay, so that means I'm going to have a new C and I'm going to use B again. I'm going to use B again. I'm not going to use any other equation. I do not know if I need to multiply B yet. Okay, so let me go back to the system, and now I'm focusing on the extern of B and C. I'm seeing that the coefficient of the extern of equation C is -4. It means that then I will need to multiply equation B by 4 in order to have the opposite value there. So it will be B times 4, or 4 times B. So let me grab this, and let me grab this. See how things are getting complicated because we need to do a lot of steps, a lot of numbers, a lot of multiplication, modifications with the system. So careful here on your writing. All right. So now we are going to have a new C, and that's the first step. So we multiply B by 4, and then we are going to add by equation C. What I'm going to do here is to distribute positive 4. So now I have positive 4 in front of x here. Then I have 4 here. And this is going to give me 12. And here this is going to give me -8. Okay, when you multiply B by 4, that's what you got. So the extern get cancelled. -7y plus 14z equals 7. So new C is -7y 14z equals 7. No, that's not the problem. Okay, so that's new C. I can do something more. Let's focus on this equation. Okay, every time you can take advantage of the structure of the equation, you are going to do that. Right now you are seeing that 7 is the common factor here, so you are going to factor out I'm going to factor out -7 because I want to have this term here positive, the one in the front. Okay, but you can just factor 7. When you factor out -7, that means that this becomes -2z and not +2. Okay, and see what we can do here. If we divide both sides by -7, we can simplify our C equation. Okay, So the new c now is y minus 2z equals -1. Okay? So every time you can make things easier, you are going to do that. Okay, so we have, I'm going to zoom out a moment. I don't know how well you see there. But what I just did, I just eliminate the x term from the equation A and equation C. Okay, the equation on the second position and on the third position. Now they do not have a term of the x term. Okay, so let me take this. Let's see how our system look after doing that. Okay, so that's how the system looks at the moment. We still do not have the triangular shape because equation C has two variables. We want to eliminate second variable on C. This point is crucial. Now you are not going to use B for anything, because if you use B, that means that you will introduce the x term, but again on A and C. You are going to leave B alone for a moment, and you are going just to focus on A and C. Okay, so using A and C to eliminate Y from C. Okay, do not use equation B. If you use equation B, because equation B has a x term, you will introduce back the x term into equation C. Okay, so now we are going to have a new C again, and that new C is going to be formed based using equation A plus equation C. But we do not know if we need to multiply something here. What we are seeing is that C now is the one that has a coefficient of 1. Y is equal 1. That's convenient here because that means, well, if we multiply equation C by the opposite value of the coefficient of the y term coefficient of equation A, then we can cancel that y term from C. So the opposite value here is -3. So we are going to multiply C by -3. Okay. So now we have -3 times C. Remember here the equation that we are going to modify is C. Okay. So A, we are using A just to eliminate the y term from C. Okay. So multiplying by -3, I'm going to distribute -3. So now I'm getting +6 here, and then +3 here. So we cancel the y term. Then we got -1z equals 4. Okay. Okay, let me verify that everything is correct. Okay, it's always what I'm doing right now is just making sure that I am getting the right numbers. Okay, this is something that you want to do when working with 3 by 3 system. Always verify each step, because just one wrong value, it will make the entire exercise incorrect, and it's going to be very difficult to going back and get a value, um, and get a value to going back and verify where the mistake is. Okay, so always try to make sure that you are getting uh, the correct answer. So let me, and that's what I'm trying to do here. I just want to make sure that I'm putting the right numbers. So I'm multiplying -3 by c. So just a moment. Let me finish this. C. So 6, 7. Okay, I see what I did wrong. Okay, so this 7 is negative. Okay, because this 8 here is negative, so +1, -7. So this is negative. Okay, so this one is negative. So it means that this number here is positive. So here it is positive. And here, since we are multiplying by a negative value, we have a -3. Now this turn into -2. Okay. Again, always verify that you are doing your calculation correct. It happened to me. I just forgot to put a negative, or I forgot to do, or I did wrong an addition between a positive and negative value. Okay, that tiny mistake would have cost me the entire exercise. Okay, so this is something that I want you to do when working with system of equations. Always stop, make sure that you are doing it correct, that you're getting the right answers. if something doesn't feel wrong, it doesn't feel right, go back, try to find that thing that you feel that you did wrong. Okay. From this point, so this is the new C. So new C is negative Z equals -2. So I just drop the 1 and just put the negative. We can simplify this as Z equals +2. Okay. And see what we have right now. So again, I'm going to write the system to have an update on how it looks. And now you can see that I have a triangular shape. Already I have the value for Z because Z is equal to 2. And we can see that on equation C. Okay, so this is the triangular shape. Now that we have the triangular shape, we can do back substitution. How are we going to do back substitution? So C, the value of Z is equal to, is 2. So we have that value. Then we are going to take equation A and we are going to substitute Z with 2. Okay, and solving this equation, we got 14, then 15, 3 divided by 15, y is going to be equal to 5. Right? And then we are going to take the last of the equation B, or the equation that we have on the top, and we are going to substitute Z with 2. Okay, so 3 times 2, and we are going to substitute y with 5, and then we are going to solve for x. Let me see if I can do this here. So we have 6 negative, so 1, x -3 if I'm not wrong. So 6 1 -3. Okay, so that is the solution of the system. See how all the things that we need to do to reach the solution. So that is why the system of equations sometimes gets ugly. And here I avoided fractions and negative, in the most part negative, or in the most part fractions. So I had some negative, but they didn't cost me like too much trouble. Yes, I made a mistake. I forgot to add a negative on my calculations, but luckily I took a moment just to verify my results. Okay, and that's something that you want to do when working with this exercise. You don't want to miss. You don't want to waste 10 minutes of your working because you didn't check that your calculations are correct. Okay, if you are 10 minutes on working with exercise, take a moment, verify that everything is correct before you move on. Okay, because you move on with an exercise, you are going to carry over with a mistake, you are going to carry over that mistake into the solution, and it can cost you a lot. Written work for this exercise. Yeah, I think all this. I can do any more here. Okay, it is working with 3x3 system, get complicated because all the steps that we need to do. They are not difficult, okay? Just tedious work to do. And it requires a lot of practice, okay? So I don't know if I'm going to scroll down slowly through the steps, okay? It won't be possible to show all the written work if I zoom out here. So we start with a 3x3 system. We decided the type of shape of the triangular shape that we wanted for this 3x3 system. The top one with the top equation with the 3 variables, the second one with 2 variables, and the last one with 1 variable, x, y, and z, and z. Because equation B has 1 as the coefficient of the x term, I use equation B as my top equation. And then I proceed to eliminate the x term from A and C using B. To eliminate the x term from A, I multiply B by -2. That's the opposite coefficient of, that's the opposite value of 2, the coefficient of the x term of equation A. When I did that modification and I add -2 B plus A, I got a new equation for A, which is 3y minus 7 and z equals 1. Then I proceed to eliminate the x term from C using B. In this case, the modification I did is multiply B by 4. Then I add it to C. So C, I change the equation C for, so the new equation C was -7y plus 14z equals -7. There was my mistake where I put positive 7 instead of -7 as the result here. Because there is a common factor, 7, I couldn't simplify equation C. So the new equation C is now y minus 2z equals 1. Okay. When I did that, I updated the system equation to see the shape and to see what we have. Then we need to proceed and focus only on A and C. Because why focusing on them and not on B? They are the only two equations that contain only two unknown variables, y and z. So we don't want to use B, because if we use B, again, we are going to introduce back, we're going to put back the x term into one of those equations. So that's why we need to avoid using B in this case. Otherwise, you will be going back, so working around, I believe is the term. So then using A and C, I focus on C, on the y term on C, so I wanted to eliminate y from C. And to do that, I multiply C by -3 and then add it to A. When I did that, I get a new C. And this C just contains one variable, and it just was z equal to 2. Then I updated again the triangular shape, or the 3x3 system. Now we have a triangular shape. Once we have a triangular shape, we can do back substitution, okay? So triangular shape here, and then back substitution below. Back substitution, I start with the equation with just one variable, solve for that variable, in this case just z equal 2. Then I use that result on the equation that has two variables. I solve for the unknown variable there. Now I have two variables, values, and then I use those values into the third equation, which has the three unknown variables. And once I substitute the value for y and z, now I can solve for x, and there is the solution. You can go further and verify that your solution is correct by putting -3, 5, and 2 back into the written-up system. And those values need to hold true for all the systems. for all the equations in the system. Okay. Any question on this one? This exercise is interesting because the exercise that we have here, let me set up this, sorry. So the exercise that we have here, two of these equations are equivalent. Can you tell me which of those two equations are equivalent? Okay, so let's try to solve this exercise by the method that we just saw, and let's see what happens. Okay. Equation A, equation B, and equation C. So I want to use B as my top equation, okay? So I'm going to change the order, and I'm going to do that. The reason I'm doing this is because the coefficient of the x term of equation B is +1. Okay. Then I'm going to eliminate the x term from A and C. So now I'm going to have a new A, and that is going to be B plus A. I do not need to do any multiplication because I have a direct opposite value here. Okay, so taking these two equations, and adding them, I eliminate the x term here, then I have positive 2y, then I have positive z, this is equal to -4. So new A is 2y plus z equals -4. Okay. Then I'm going to do the same. I'm going to get a new B, and to get a new B, what I'm going to do is to multiply, sorry, new C, I'm going to multiply B by 3 because -3 is the coefficient of the x term of C, and I'm going to add that by C, or to C. So let me copy B, Remember that we are multiplying b by 3, so I have 3 here. I have 3y here. I have 3z here, and then I have 3 here. Okay, so now I cancel the x term. When I add them, then I have 2y, and then I have z, and this is going to be equal to -4. Okay, so new c is 2y plus z equals -4. Let me update the system and we are going to see what's going on happen there. So new a is 2y plus z equal -4, and new c is also 2y z plus c equals -4. So you are in this position, and if you try to cancel, so if you try to cancel terms, the y term of c using a, what you are going to do is to cancel both. What you are going to have for c is an equation 0 equals 0, because these two are equivalent. So when you have two equations that are the same in a three-body system, what you are going to do is you're going to solve for one. You're going to take those, so they are the same, right? So let's isolate for one of the unknown variables here. Okay, so I'm just going to copy this below to show you what we're going to do. Okay, but remember that these two are the same. A and c are the same. So if I'm going to isolate for the z, because it's the easiest value to solve for. Okay, what does this mean in this exercise? It means that now the value of the unknown variable, the variable z, depends on y. So what we are seeing here is that z is a function of y, or an equation of is a function of y. If we can work with the vocabulary just a little bit, in that equation that we are seeing there for z, y is going to be the input and z is going to be the output. Okay, so now z is in terms of y, in terms of y. It means that it depends on y. This is important because then to reach the solution of the system, we are going to have our solution based on y, in terms of y. What does this mean is that y is going to be the independent variable in this system, and z and x are going to depend on y. Okay, so z, the solution that we reach for c is -4, -2y. So z, that is the solution for z. Y is going to, we are going to leave y alone because y is going to be the independent variable here. Now, because we have a third variable which is x, and the only independent variable here is going to be y. Now x need to be written in terms of y, something very similar to what we did with z. z equals -4 equals the -4 minus 2y. So now we need to have x equal to something but in terms of y. And how are we going to do that? Well, if we take the first equation B, where we have x, and we substitute z with this equation, so it will be okay. So what I did, I substitute the value of z in the first equation. So see that -4 minus 2y, it is in the place where z is in the first equation. Okay, so that brings that the first equation only have two variables. So I think I choose continue here down below. Let me move this a little bit here because I'm working with okay. So this step is in continuation of this that we have here. Okay. Then we combine like terms, so we are going to have -y plus 2y is plus y, and then this 4 stay here, but we are going to move everything to the right side, everything but x, because now we are going to have an equation for x in terms of y. So it will be -y and -3 when we subtract 4 on both sides of the equation. So now x, we have an equation for x. Maybe I should put this here. We have an equation for x in terms of y. So now we can reach a solution. It is not going to be a unique solution, as the solution of the system depends on the independent variable y. So here we have an infinite amount of solutions. Okay, but the important thing here is that the variable x and the variable z, in this case, the way we solve it depends on the variable y. So for any value of y, we're going to have a value for x and a value for z. So that is our solution. And again, I cannot present to you all this written work, so I'm going to just go in a moment. I'm going to show you. Okay, so if the system will have a unique solution, you will have to check here and then put those values, right? If the system has no solution, then you check here at the beginning. Because of the system have infinite many solutions, and the way we solve it was that solution depend on the variable y. You are going to check here, and then you are going to enter the equation for x in terms of y and the equation for z in terms of y. Okay. So at the beginning, so let's go back to this exercise. Let's review it. When we start working with this exercise, I knew that there were two equivalent equations because I prepared this example for you, right? But if we were the first time that if I was working the first time with this exercise, initially I wouldn't be able to identify that we have equivalent equations here. So I started working normally with this system, the 3x3 system, by the method that we just review or discuss, that we want to turn the system in a triangular shape and then to do back substitution. So I did that. I just follow the general procedure to solve three-by-three system. So I started by changing the order of A and B, flipping the order because B has a leading coefficient in the x term of +1, so that is convenient to use. Then I proceed to use B to eliminate the x term from A and C. To get the new A, I just add both equations, A and B. To get the new A, to get the new C, I needed to multiply first B by 3 and then add them together. After I eliminated the x term from A and C, I noticed that I have two of the same equation. A and C are the same. In this scenario, I was able to find an expression for the infinite amount of solutions. In this scenario, since I isolate for Z the C equation, so I rewrite Z, or I found an equation of Z in terms of Y. Now Y becomes the independent variable in this system. Because Y is the independent variable, then I have Z as -4 minus 2y. Y is just the independent variable, but then the x variable need to be written as well in y terms, in a y term, or in terms of y. Okay, so what I did is just I substitute the equation, the expression for z for the first equation, okay, and then I isolated for x. When I did that, I noticed that I have now an equation of x that depend only on the variable y. Hence, I have mathematical expressions for each of the three variables. X is equal to y minus 3. Y is just y because it's the independent variable. -4 minus 2y is the expression for the variable z. Okay, and that is how you get the solution. Any question? Okay, 3x3 system are commonly used on everyday matter, or everyday, like, how do you say that? Everyday matter, I believe, in the work industry. The thing is that sometimes we do not realize that we use system of equations. Okay, so let's see how a 3x3 system can be used to solve this exercise. So the exercise says a restaurant buys baked goods from a local baker. The table below gives the number of loaves of bread, bags of cookies, and cupcakes the restaurant bought over the course of 3 weeks. The restaurant buys no other baked good from the baker. Okay, so then we have a table where we have the data of the baked goods that this restaurant bought, right? Then we have the question: if the restaurant spent 57 on baked goods in week number 1, 89 in week number 2, and 68 in week number 3, what is the cost for each item? Okay, so now we want to find the unit cost of each item, and the only thing that we know is that how many items were bought, okay, per week in these 3 weeks. And the other data that we have is that we know that in week 1 we've spent 57, we spent 89 in week number 2, and then 68 on week number 3. So how can we use a system of equation, more specifically a 3x3 system, to know the unit cost of each item. Okay, so because we are getting the result or the amount that the restaurant spent per week, so now each week is going to be the equation. Okay, so each week is going to form the data from each week is going to form an equation, because when we from this week we can get the amount that the restaurant spent. So from week 1, the amount of the amount of the restaurant spent was 57. From week 2 was 89, and from week 3 was 68. Okay, so we do not know yet exactly how we are going to write the system here, but we know that from week 1 we got a conclusion. We got 57, the amount of the restaurant, the amount that the restaurant spent. From week 2, 89, and from week 3, 68. Furthermore, we know the amount that this restaurant bought of each item. Each item here is acting as the unknown variable. Okay? The unknown variable, the cost of each item is unknown. The cost of each item is unknown, because that's what we are looking for, the unit cost of each item. So that is going to be this is the unknown variable here. So we can assign variables to the cost of each item. So the loaf of bread, we are going to assign X for the unknown cost of the loaf of bread. We are going to assign Y to the unknown cost of the bag of cookies. And we are going to assign Z to the unknown cost of cupcakes. With that information, we can now turn this table into a system of equation. Okay, so from week number 1, the equation that we got, equation A, it will be, remember that what we are getting as a result from each week is the amount that the restaurant spent. So we need to construct an equation that at the end is equal to 57. Okay, because that is how we are treating this problem. So we know that we bought 5 loaves of bread, but the unit cost, or the cost for each item here, is unknown. So 5 times X is the amount that was spent just to buy the loaf of bread. But that's not the only thing that we bought. Bag of cookies as well. Well, there were 8 bags of cookies that were bought, but the unknown cost of each bag is the cost of each bag is unknown. So A times Y. The same thing for the cookies. 4 times Z. What we know about week number 1 is that, well, the amount that the restaurant spent was 57. So if we add all this, we need to get 57. And that's from week number 1. From week number 2, we do the same, but this time now is 9, 8, 9, and 7. And this is equal to 89. From week number 3, we got 8 loaf of bread, so 8 times X, 4 times Y, and 5 times Z. See how a word problem can turn into a mathematical problem, and then we can use the mathematical properties that we know, or the mathematical techniques that we know to solve the real life problem. So this is the goal of mathematics, to turn maybe complex situations into something that we can write down, and we can evaluate, and we can use properties from mathematics to solve the problem initially, okay? The initial problem. So that is the system. So I should erase this. Okay, this is just from when week 1, week 2, and week 3. That's just telling us from when I took those, or from when I built those equations. So this is the system that we have. Okay, so with that system, solving to that system, so if when you solve for x, you are getting the cost of loaf of bread. So that is going to be x, bag of cookie is going to be y, and cupcake is going to be the value of z. Okay. This system gets ugly when you try to solve it, because you are going to have fractions, you are going to have bigger numbers, huge numbers. Okay. But it is a very good system to practice the technique that we just discussed. Okay. You should do correct, and you apply correct the process in this exercise that gets ugly, and I believe you are going to be good for the rest of the exercises. Okay, let me give you no, I don't. Okay, no, I don't have the correct answer here for this one. Okay, but what I wanted to discuss with you is how to turn this word problem into a 3x3 system. Okay, after that you are going just to solve the system, and solving the system you are going to solve the real life problem. Okay, all right, so we have reached our last topic for the entire semester. So what is left to do is to prepare for test number 3 and the final. Let me see what we have here. Let me bring this up. So today's 29. So now we have discussed unit number 14. On Friday you have quiz number 6. Test number 3 is the 8th of December. So we have 2 more meetings where we can discuss and review material, and then after that I'm not going to meet you again unless you have questions, maybe quick questions. Remember that next week, the week number 16, then it will be the final week, so you will have attending, or you will have to focus on other tests. As well, you need to focus on the final exam that is on Wednesday. Okay, so we have 2 more meetings to get ready for test 3 and final exam. So please try to take these 2 remaining weeks to get ready for test 3 and the final exam. So any questions that you might have, please try to bring them on Wednesday, on next Wednesday, this coming Wednesday off, or next Monday. Okay, so you can get ready for the final assessments. Right. So other than that, we have finished. If you don't have questions, thank you for being here today. I will see you on Wednesday. Okay, and remember that we are getting ready to finish our semester. Okay. Any questions? All right. If there's no question, thank you so much.